Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about spectroscopy. What is spectroscopy? Spectroscopy is the tool for a study of atomic and molecular structure. It deals with interaction of electronic radiation with matter, involving the measurement and interpretation of the extension of absorptions or emission of electromagnetic radiation by molecule. So you have the spectroscopy like ultraviolet, UV visibles, infrared, nuclear magnetic resonance, and the radiation absorbed UV visible, infrared and radio. Effect on the molecule, changes in electronic energy level within the molecule, changes in vibrational and rotational moment of the molecule, induces change in the magnetic properties of certain atomic nuclei. Now friend, most important consequence of such interaction is the energy is absorbed or emitted by the matter is discrete amount called as quantum. UV radiation start at blue end of visible light 4000 angstrom and ends at 2000. It divided into two special regions near UV region 2000 angstrom to 4000 angstrom, far or vacuum UV regions or below 2000 angstrom. UV spectroscopy involved with electronic excitations. Now friend, absorptions and emission spectra. Spectroscopy mainly concerned with interaction of electromagnetic radiation with matter. After interaction, there may variation in intensity of EMR with frequency. Instrument which record this variation in intensity known as spectrophotometer. Two-way in which interaction may absorb sample itself emit radiations and called as emission spectra. Absorb radiation from continuous source called as absorption spectra. Terminology: wavelength lambda, distance between two successive maxima of one electromagnetic wave expressed in angstrom unit. Frequency: number of wavelengths passing through a given point per second. Unit hertz or cycle per second. Wave number, number of wave per centimeter in vacuum. Reciprocal of wavelength expressed as per centimeter. What is the relations between frequency, velocity and wave number? Wave frequency is equal to 1 by lambda c. C by frequency lambda is equal to V by c. This is the electromagnetic spectrum. You can see gamma, X-rays, ultraviolet, infrared, microwave, radio wave. Origin and theory of UV visible spectroscopy. Ultraviolet absorption spectra arises from transition of electrons or electrons within molecule. UV emission spectra arises from reverse type of transitions. Electron undergoes transition from lower to higher energy level, and this energy difference given by E is equal to h nu. But actually energy difference between ground and excited state of electrons E1 minus E0 is equal to h nu. So total energy of molecule is sum of electronic, vibrational and rotational energy. UV visible spectroscopy is the measurement of absorbance or transmittance of radiation in the ultraviolet and visible region of the spectrum. It arises from transitions of electrons, stage 1 m plus h nu m star, excitation of a species by absorptions of photon with limited lifetime, stage 2 m star give new species, relaxation by converting m star to the new species by photochemical reactions. Friends, sigma electrons involved in the saturated bonds found in the carbon, hydrogen in the paraffin, Energy required to excite sigma produced to electrons more than produced by the UV light. Pi electrons involve unsaturation hydrocarbons present in trienes and aromatic compound. N electron, it does not involve in the bonding of the molecules. You can see the transitions usually, and pi star transition forbidden. Allowed transition having E max into 4 or more, and this transition due to pi star transition. In 1,3-butadiene exhibits absorption at 270 nanometer and has E max 21,000 to represent allowed transitions. Forbidden transitions having epsilon max less than 10 to the power 4. You can see the transitions. You can see the transition regions. Energy required for various transition are in order: sigma star, n2 sigma star, pi star, n pi star. Thus n pi star transition require less energy than pi star or sigma star. Now component of a spectrophotometer: source, monochromator, sample compartment, detector, recorder. So you can see the sample, radiance source, wavelength selector, solvent, photodetector, readout. Block diagram of instrumentation of UV speakers. You see the light source, entrance slit, monochromator, exit slit, sample, detector, amplifier, readout. Now you see a schematic representation of single beam UV visible spectrophotometer and schematic representation of double beam UV visible spectrophotometer. So distribution of energy through the spectrum is a function of temperature. Tungsten filament lamp used for region 350 nanometer to 2000 nanometer. Problem: due to evaporation of tungsten, life period decreases. It is overcome by using tungsten halogen lamp. Halogen gas prevents the evaporation of tungsten. For ultraviolet regions, hydrogen discharge lamp consists of two electrodes containing in deuterium filled silica envelope, gives continuous spectrum in region 185 to 300 nanometer. Above 380 nanometer emission is not continuous. UV visible spectrophotometer have both deuterium and tungsten lamp. Selections of lamp is made by moving lamp mounting or mirror to cause the light fall on monochromator. Deuterium lamp radiations emitted is 3 to 5 times more than the hydrogen discharge lamp. Xenon is stored under pressure in 10 to 30 atmosphere. It possesses two tungsten electrodes separated by 8 cm. Intensify of UV visible radiation more than hydrogen lamp. Faint mercury arc vapor filled under pressure. Excitation of mercury atom by electric discharge. What is the monochromator? Provides beam of radiant energy of a given nominal wavelength and a spectral bandwidth. Parts of the monochromator: an entrance slit, collimator, grating, a collimators, and exit slit. Filter: glass filter made from pieces of colored glass which transmit limited wavelength range of a spectrum. Color produced by incorporations of oxide of vanadium, chromium, iron, nickel, copper. Wide band with 150 nanometer. Gelatin filter consists of mixture of dyes placed in gelatin and sandwiched between glass plates. Bandwidth 25 nanometer. Interferometric filter, bandwidth 50 nanometers. So prism bends the monochromatic light. Amount of deviation depends on wavelength. Quartz prism used in UV regions. Glass prism used in visible region spectrum. Functions: they produce nonlinear dispersions. You can see here sunlight, focusing lens, slit, collimating lens, prism, focusing lens, detecting screen, red violet. This is the mechanism of working of prism. Grating: large number of equi-spaced line on glass blank coated with the aluminum film. Blaze angles: normal to groove face, normal surface filter. Simple cell. Spectroscopy requires all materials in the beam path other than the analyte should be transparent to the radiation as possible. The geometries of all components in the system should be such as to maximize the signal and minimize the scattered light. The material from which a simple cuvette is fabricated control the optical window that can be used. So some typical materials are optical glass 335 to 2500 nanometer, special optical glass 320 nanometers 2500 nanometer, quartz infrared 220 to 3800 nanometer, quartz far UV 170 to 2700 nanometer. Keep the cuvette clean, don't clean with paper products, store dry, don't get fingerprints on them, store carefully and gently. Now detector. Three common types of detector are used: barrier layer cell, photo cell detector, photomultiplier. Photovoltaic cell or barrier layer cell, they are primarily used for measurement of radiation in visible region. Maximum sensitivity 550 nanometer, consists of flat copper or Fe electrode on which semiconductor such as selenium is deposited. On the selenium, a thin layer of silica, silver or gold is puttered over the surface. Now friend, barrier layer cell. A barrier exists between the selenium and iron which prevent the electrons flowing through iron. Therefore, electrons are accumulated on the silver surface and these electrons are produce voltage. So photo cell detectors is consist of high sensitive cathode in the form of half cylinder of metals which is evacuated. Anode also present which fixed along the axis of the tube, and photocell is more sensitive than photovoltaic cell. So photomultiplier tube you can see here it is generally used as detector in UV spectrophotometer. It is used the combination of photoiodide and electron multiplier. It consists of evacuated tube, contains photocathode and 9 to 16 electrodes known as diodes. So signal from detector received by the recording system, the recording done by the recorder band. Sample handling, important to reposition the cuvette properly. To clean the cuvette, lens paper soaked in the spectrograde methanol which is held by homostat is used. When cuvette are cleaned, the methanol film left evaporates quickly, leaving cuvette surface free of contaminants. For maximum precision, syringe are used to change the solution, leaving the cuvette in the same place. So single beam spectrophotometer and double beam spectrophotometer. Advantage of double bond spectrophotometer: it is not necessary to continuously replace the blank with the sample to adjust the auto-zero. The ratio of the powers of the sample and reference is constantly obtained. It has rapid scanning over the wide wavelength region because of the above two factors. So Lamberts law: intensity beam of parallel monochromatic radiation decreases exponentially as it passes through a medium of homogeneous thickness. Absorption is proportional to the thickness path length of the solutions. K is equal to absorption coefficient defined as the reciprocal of the thickness which required to reduce to light to 1 by 10 of its intensity. So Beer's law: intensity of a beam of parallel monochromatic radiation decreases exponentially with the number of absorbing molecules. Absorption is proportional to concentration. Combination of two law of yield Beer's Lamberts law you can see here. So deviation from Beer's Lamberts law: from the Beer's law, plot the absorption against the concentration. The straight line passing through origin is obtained. Deviation is due to the following factor: the foreign substance having color particles may affect the absorption and exclusion coefficient. Deviation also occurs colored solute ionized or dissociate in solution, for example benzyl alcohol in chloroform, due to presence of impurities that follow or absorb at the absorption wavelength. If monochromatic light is not used, deviations may occur if width of the slit is not proper, if the solution species undergo polymerization. So transmittance I naught by IT, transmittance, percentage transmittance, absorbance also termed as extinction coefficient, optical density. Friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.